I really hope you enjoyed our nuggets that dealt with fiber channel. And if you did, you're going to love this nugget as well, because we're going to look at something that Cisco refers to as their unified fabric. This is the amazing ability to take that fiber channel traffic, encapsulate it in Ethernet, and unify over a single infrastructure both your LAN traffic and your SAN traffic. Let's jump in. I think there's a rap song that talks about it's all about the Benjamins, referring to how it's all about money. Well, in this particular nugget, it's all about the acronyms. Yeah, we're going to see a bunch of them, and certainly there's fiber channel over Ethernet that we'll examine, and that's the star of the show, right? But we'll also take a look at priority flow control as a way in which to ensure think about the modern day data center. There's LAN stuff and there's SAN stuff. And this equipment and these links are specific for the SAN, and this equipment and those links are specific for the LAN. What if we could marry those two? What if we could take the SAN traffic and send it over the same equipment and links as we are doing the LAN traffic? Would there be benefits? There sure would be. The first benefit we would see would be a reduction in the number of different server adapters that we need to manage, right? In the LAN, we know there are network interface cards. In the SAN, we know there are host bus adapters. What if we could just buy one thing, a CNA? This acronym stands for Converged Network Adapter. And converged means that it has the ability to understand the would also allow us to take advantage of great layer 2 domains with complete multipath capabilities, right? What we could do would be we could take advantage of virtual port channels, we could take advantage of Cisco's fabric path technologies, and we could have these really large multipath robust layer 2 domains for the LAN and the SAN. Overall, total cost of ownership would be reduced because we would be dealing with unified equipment instead of separate LAN and SAN equipment. And it would be really excellent from an operational standpoint, right? So lots of really compelling reasons to look at a unified fabric of fiber channel over Ethernet. Now, please keep in mind that this isn't going to be all that easy. I mean, think about it. The LAN focuses on Ethernet connectivity, and the SAN focuses on fiber channel connectivity. The LAN packet loss happens, and it's okay. The LAN can deal with it. In the SAN, we can't deal with packet loss. So the engineers really had to get very creative with the creation of technologies in order to marry these very different environments. So to pull this off, there needs to be a lot of requirements that are met. The first one I want you to know is that the entire fiber channel frame needs to be carried in the payload of a single Ethernet frame. So we're going to have some big Ethernet frames. We call these, of course, jumbo frames. So we need to support jumbo frames in order to pull this off. Also, think about layer 2 naming. We need to be able to take port worldwide names, and we need to be able to map those to MAC addresses that are used in an Ethernet environment. And we need an additional protocol to handle login of fiber channel devices across a unified fabric. So the engineers invented FIP. This is Fiber Channel over Ethernet Initialization Protocol. Okay, so when we see IP here, think initialization protocol. Next, we need lossless delivery in the Ethernet environment. This means no packet loss. And in this nugget, I'll show you some solutions that they engineered for this. And finally, a requirement that we've already mentioned is we're going to need a minimum of 10 gigabits per second as the technology that is used for this unified fabric. So pretty remarkable. We take the fiber channel information and we encapsulate it in our Ethernet frame. The ether type value that is utilized in order to identify this is 8906 in hexadecimal. If you look inside the Ethernet packet, you will see that, frame I should say, there is a 4-bit version field. And then you'll see in there the encapsulated fiber channel information. And that's it. Everything else in the Ethernet frame is what we would expect, like the source MAC address, the destination MAC address, the IEEE 802.1q tag would be in there. Everything else would be normal. Now, what about the size? Well, a fiber channel frame consists of 36 bytes of headers and as many as 2,112 bytes of data for a maximum size of 2,148 bytes. So the encapsulated fiber channel frame has all the standard headers, and we need to accommodate this maximum fiber channel frame in our fiber channel over Ethernet frame. So we define a default MTU for the fiber channel over Ethernet of 2,240 bytes. So there's our max MTU for this unified fabric environment. Now, do you remember our fiber channel architecture where we had the FC0 handling the physical interface stuff, the FC1 handling the encoding, the FC2 handling the framing and flow control, generic services at layer 3, and then upper layer protocol mapping at layer 4? Well, think about it. To pull off this fiber channel over Ethernet environment, we need to replace those lower 2 layers with new technologies, right? So we have our Ethernet physical layer that is going to be utilized. Trouble spelling today, aren't I? The Ethernet physical layer that's going to be utilized, the media access control layer, and then we have the what's called fiber channel over Ethernet logical endpoint. Yeah, this is going to be a key ingredient. And then what happens is we have FC2, just like there, FC3, and FC4. So notice FC1 and FC0 are modified so that we can take Ethernet and incorporate it into Fiber Channel and then map, if you will, the Ethernet stuff to the upper layer Fiber Channel stuff. That's the purpose of that logical endpoint. So what this really means to us is that our traditional SAN equipment, the MDS stuff, can see the Fiber Channel higher layers that lives inside them. Mastering all the different terminology that we have in a Fiber Channel infrastructure, like our N ports and our F ports and our Ethernet nodes. And here we have one, and notice that's the converged network channel over Ethernet. What do we call this particular node? What do we call this whole thing? That would be the initiator and its converged network adapter. Well, we call it an E, no space, node. There you go. So one word, E node. This is a reference to an Ethernet NIC that can operate as a Fiber Channel node port. So it can be an N port, but because it's Fiber Channel over Ethernet, we give this node a particular name. We give it an E node. Now, how do we refer to the port, though? What's the port designation? Well, that port designation is called a VN port. Terminology. And by the way, speaking of terminology, what do we call a Fiber Channel over Ethernet switch? Yeah, this is a switch that has the ability to switch Fiber Channel and also the ability to switch Ethernet. We call this a Fiber Channel Forwarder, or FCF. So here we have our VN port on a host. Here's our VF port on the Fiber Channel Forwarder. And then here's another Fiber Channel Forwarder. We'll connect those with, you guessed it, VE ports. What is the protocol that is going to be responsible for making all of these associations? Well, we mentioned it earlier. It's FIP. Remember what FIP stands for. It is our Fiber Channel over Ethernet Initialization Protocol. And that makes perfect sense now when we think and we look at this topology and we think of these devices properly initializing with each other. Now, the IEEE got involved to really help with Unified Fabric. Specifically, the IEEE got together with what they called the DCB set of standards. This stands for Data Center Bridging. And it's a set of IEEE standards that really help provide the foundation for the Unified Fabric work that Cisco has done. Here are the standards. There's 802.1qBB, or Priority Flow Control. What this does is really ensures that there's a system in place where there'll be lossless delivery of these Fiber Channel over Ethernet frames. Remember, Ethernet can tolerate loss, Fiber Channel can't. Therefore, by association, since Ethernet is carrying the Fiber Channel, we can't have any of those Fiber Channel over Ethernet frames dropped. Then there's ETS, known by 802.1q-AZ, Enhanced Transmission Selection. This provides bandwidth management and priority selection of traffic on the network. Then we have 802.1q-AU. This is quantized congestion notification. And this obviously provides congestion awareness and avoidance. It's actually an optional standard that vendors can choose on their own whether or not they are going to implement it. And guess what? Cisco does not implement it. As a result, you really shouldn't see questions in your certification exam environment involving QCN. Why did I bring it up? Well, because I want you to have a full knowledge. I want you to have the full story here in this course. And finally, Data Center Bridging Exchange, 802.1q-AB. This is critical, really, that we have this ability to exchange between devices that want to engage in fiber channel over Ethernet. We want them to be able to exchange Let's jump into some exam time. You have a fiber channel over Ethernet host connecting to a fiber channel forwarder that connects to another fiber channel forwarder. What's the link called between the fiber channel forwarders? Interesting. VN to VN? Virtual node to virtual node? No, I think we can throw that one out. Virtual fabric to virtual fabric? Close. How about VE to VE? Yeah, think expansion. Think virtual expansion. That appears to be our correct answer, but let's just double check that by taking a look at the last one. VN to VF? No, that's how the host would actually connect to the FCF, right? So that's there. And then when we connect to another FCF, that's when we're going to get our VE to VE. So there we go. It was indeed C. Gotta love how you're going to be able to take what you've mastered in this CBT Nugget course and put it to work for you immediately in certification. So in this very important nugget, we took a look at fiber channel over Ethernet. And one of the things that we did was we really looked at the benefits, right? What pluses does fiber channel over Ethernet bring to our environment? And then we highlighted some of the IEEE designations that make it work, like priority flow control and enhanced transmission selection. And then we discussed that data center bridging exchange protocol, and we saw where those particular ingredients fit in this exciting world of unified fabric. Remember, that is the marketing term that you see heavily utilized by Cisco involving this set of technologies. Well, I sure hope this has been informative for you, and I'd like to thank you for viewing.